Terminology in cryptography. In this video, we are going to see about terminology in cryptography. Cryptography. The word crypto is derived from the Greek word called kryptos. Cryptography is the method of storing and transmitting data in a particular form so that only those for whom it is intended can read and process it. The term is most often associated with scrambling plain text, ordinary text, sometimes referred to as clear text, into ciphertext, a process called encryption, then back again, known as decryption. Plain text. In cryptography, plain text refers to any message that is not encrypted, contrast with ciphertext. Plain text refers to textual data in ASCII format. Plain text is the most portable format because it is supported by their every application and machine. Encryption. Encryption is the conversion of data into some other format using the key called a ciphertext that cannot be easily understood by unauthorized people. To read an encrypted file, you must have an access right to the secret key that enables you to decrypt it. Encryption is the effective way to achieve data security. Ciphers. Ciphers are a secret system of writing that you or we use to send message. It is an algorithm for converting plain text to ciphertext. In the cipher, data has been encrypted. Ciphertext. Ciphertext or ciphertext is the result of encryption performed on plain text using an algorithm called a cipher. Here, the plain text is encrypted with shared secret key and converted into a ciphertext. Decryption. Decryption is the process of converting encrypted data back into its original form so it can be understood. Decryption is the reverse process of encryption that converts the ciphertext into plain text information that has been encrypted in secret format. Decryption requires a secret key to recover information. Key. A key is a variable or value that are applied using an algorithm to a string or block of plain text to produce encrypted text or to decrypt the encrypted text. The information, that is key, used in cipher is known to sender or receiver only. The length of the key is a factor in considering how difficult it will be to decrypt the text in a given message. Cryptanalysis. Cryptanalysis refers to the study of ciphers, ciphertext, or cryptosystems for finding the plain text and/or key. Cryptanalysis is the decryption and analysis of codes, ciphers, or encrypted text. Cryptanalysis uses mathematical formulas to search for algorithm vulnerabilities and break into cryptography or information security systems. Cryptology. Cryptology is the study of mathematics, linguistics, and other coding patterns. Cryptology is equal to cryptography plus cryptanalysis. Cryptology as number theory and its application of formulas and algorithms which underpin the cryptography and cryptanalysis. Concept of security aspects. In this video, we are going to learn about concept of security aspects. Cryptographic systems are quite complex. This makes them vulnerable to a variety of attacks. For example, Harish sends a message to Bob. If the attack succeeds, then unknown person can able to see Harish and Bob's messages or modify the messages in their names. The most common security issue is keeping the cryptographic keys secure. However, sender and receiver should be careful with their keys. The implementation of a cryptographic system may have a bug that allows intruder to crack the system. The three aspects of information security are security attack, security service, security mechanism. Security attacks. In this video, we are going to see about security attacks. Any action that compromises the secrecy of information owned by an organization. Types of security attacks are passive attacks, active attacks. Passive attacks. A passive attack attempts to learn or listen the information from the system, but they won't change the information. The goal of the opponent is to obtain information that is being transmitted. Two types of passive attacks are release of message contents, traffic analysis. Release of message contents. A telephone conversation, an electronic mail message, and a transferred file may have confidential information. We would like to prevent the information from the attackers during transmission. Traffic analysis. Traffic analysis is a subclass when the contents of the messages are masked. Even if the opponents captured the message, could not get the information from the message. The common technique for masking contents is encryption. Active attacks. Active attack attempts to alter system resources or affect their operation. Active attacks divided into 4 categories: masquerade, replay, modification of messages, denial of service. Masquerade. A masquerade takes place when one entity pretends to be a different entity. A masquerade attack usually includes one of the other forms of active attack. For example, authentication sequences can be captured and replayed after a valid authentication sequence has taken place, thus enabling an authorized entity with few privileges to obtain extra privileges by impersonating an entity with those privileges. Replay. Replay involves the passive capture of a data unit and its successive retransmission to create an unauthorized effect. Modification of messages. Modification of messages means that some portion of a legal message is changed or that the messages are delayed or reordered to produce an unauthorized effect. Denial of service. The denial of service prevents or inhibits the normal use or management of communications facilities. This attack might contain a specific target. Example, the Security Audit Service. Security services. Now let us see the working process of security services. The goals and services of information security are as follows. Confidentiality, integrity, availability, authenticity, non-repudiation, access control. Confidentiality. Confidentiality means maintaining secrecy during transmission of information or when it is stored. Confidentiality refers to limiting information access and disclosure to authorized users and preventing unauthorized access. Authentication methods like user IDs and passwords are used to provide the same, which means that confidentiality is focused on the data privacy and limiting access to individual users based on their rights. Integrity. Data integrity means maintaining the accuracy and consistency of the data. Integrity refers to the trustworthiness of information resources. It also means that the change made to the stored information need to be done only by authorized entities and through authorized mechanism. It requires an audit trail mechanism for maintaining the details about changes made to information stored and also a fallback position in case the changes are proved to be unfavorable. Availability. Availability refers to the availability of the required information resources. Availability, like other aspects of security, may be affected by purely technical issues, natural phenomena, or human cause. The information system should be capable of providing the required information when needed. Thus, many security controls are used to make the information available in all situations. Authenticity. Authenticity is an owned integrity. It is to ensure that the data transactions, communications, or documents are genuine. It provides authentication to both the persons involved in the transaction This morphs into authentication protocol, where the verifier checks if the data record from a specific person. Non-repudiation. Non-repudiation is a form of integrity control which ensures that once a party has made a statement, they cannot make any changes to the statement later. It is an extension of authenticity, and it adds an extra feature by which third parties can be convinced. Normal authenticity is between a prover and a verifier. The verifier becomes convinced that the data at hand really comes from the prover. With non-repudiation, the verifier also obtains a proof that he may show to a third entity who would become equally convinced. This is the basis for digital signatures. Access control. It is a bridge between confidentiality, integrity, and authenticity. It begins with authentication and then works as what data the authenticated individual may access, where access is a combination of reading and writing. It ensures the proper enforcement of authentication. It ensures that only the limited data related to that particular user in accordance with his rights is accessible to that user. Security mechanisms. In this video, we are going to see about security mechanisms. A process that is designed to detect, prevent, or recover from a security attack is called security mechanism. Security mechanisms are defined in X.800. These mechanisms are divided into two types: specific security mechanism, pervasive security mechanisms. Specific security mechanisms. Specific security mechanism might be included into the suitable protocol and give some of the OSI security services: encipherment, digital signature, access control, data integrity, authentication exchange, traffic padding, routing control, notarization. Encipherment. The process of transforming data into non-understandable form by use of mathematical algorithms is called encipherment. Digital signature. Digital signature is a mathematical system for representing the authenticity of a digital message or document or account. Access control. A range of mechanisms that enforce access rights to resources. Data integrity. A range of mechanisms used to guarantee the integrity of a data unit. Authentication exchange. A mechanism planned to guarantee the individuality of an entity by means of information exchange. Traffic padding. The process of inserting bits into the gaps in data stream to frustrate traffic analysis attempts. Routing control. It enables the selection of secure routes for certain data and allows to change route, especially when security is suspected. Notarization. The use of a trusted third party to guarantee certain properties of a data exchange. Pervasive security mechanisms. Pervasive security mechanisms are not specific to any particular OSI security service. Variety of pervasive security mechanisms are: trusted functionality, security label, event detection, security audit trail, security recovery. Trusted functionality. Trusted functionality is perceived to be correct with respect to some criteria. Security label. the marking bound to a resource that names the security attributes of that resource. Event detection, detection of security relevant events. Security audit trail. It is an independent review and inspection system of records and activities of collected data. Security recovery. It takes recovery actions and deals with requests from mechanisms such as event handling. Attack types. In this video, we are going to learn about attack types. Attack models or attack types are the categorization of cryptographic attacks, denoting how much information a cryptanalyst have access to when trying to break an encrypted message. Some common attack models are interruption, interception, modification, fabrication acting as other. Interruption. In general, interruption refers to the situation in which services or data become unavailable, unusable, destroyed, and so on. In interruption, the cutting wire lines and jamming wireless signals or makes the packets to drop. In this sense, denial of service attacks by which someone maliciously attempts to make a service inaccessible to other parties is a security threat that classifies as interruption. Interception. Interception refers to the situation that an unauthorized party has gained access to a service or data. A typical example of interception is where communication between two parties has been overheard by someone else. Interception also happens when data are illegally copied, for example, after breaking into a person's private directory in a file system. Here, tapping of a conversation between Alice and Bob by Dot. Dot will hear the message transferred by Alice to Bob but does not do any modification. Modification. Modifications involve unauthorized changing of data or tampering with a service so that it no longer adheres to its original specifications. Examples of modifications include intercepting and subsequently changing transmitted data, tampering with database entries, and changing a program so that it secretly logs the activities of its users. Here, the information passed by Alice to Bob is intercepted by Dart and replaced or modified and sent to Bob. Fabrication. Fabrication refers to the situation in which additional data or activity are generated that would normally not exist. For example, an intruder may attempt to add an entry into a password file or database. Likewise, it is sometimes possible to break into a system by replaying previously sent messages. Fabrication attack is also called as impersonation. Impersonation means acting as other. Classical cryptography. In this video, we are going to see about classical cryptography. The day-old cryptographic methodology that consists of two basic components of classical ciphers: substitution cipher, transposition ciphers. Substitution cipher. Letters are replaced by other letters. Transposition ciphers. Letters are arranged in different order. The classical cryptography may be monoalphabetic ciphers, polyalphabetic ciphers. Monoalphabetic ciphers. Once the key is chosen, each alphabetic character of a plain text is mapped onto a unique alphabetic character of a ciphertext. The monoalphabetic ciphers are the shift cipher or Caesar cipher, the substitution cipher, the affine cipher. Polyalphabetic ciphers. In polyalphabetic ciphers, each alphabetic character of a plain text can be mapped onto m alphabetic characters of a ciphertext. Usually, m is related to the encryption key. The polyalphabetic ciphers are the Vigenere cipher, simple substitution cipher. In this video, we are going to see about simple substitution cipher. In simple substitution cipher, the message is encrypted by substituting the letter of the alphabet and places ahead of the current letter. Substitution ciphers, despite having 26 factorial possible permutations, are actually very insecure and are easily solved using letter frequencies. For example, the substitution with n is equal to 3, which acts as the key. The amount of the shift is called key. Using the key, we can encrypt the given message. The simple substitution with the shift of 3 is known as the Caesar cipher because it was reputedly used with success by Julius Caesar. Encipher, plaintext, computer science. Using the key of 3, we can encrypt the plaintext message. Cyphertext, FRPS-XW-HVFL-HQFH. Simply replacing each letter by the letter that is 3 positions ahead of it in the alphabet. Decipher, ciphertext, FRPS-XW-HVFL-HQFH. Plaintext, computer science. To decrypt, we simply look up the ciphertext letter in the ciphertext row and replace it with the corresponding letter in the plaintext row, or simply shift each ciphertext letter backward by 3. Transposition cipher. In this video, we are going to learn about transposition cipher. Transposition ciphers are a bit different to substitution ciphers. Whereas substitution ciphers replace each letter with a different letter or symbol to produce the ciphertext. In a transposition cipher, the letters are just moved around. The letters or words of the plaintext are reordered in some way fixed by a given rule, that is the key. One example of a transposition cipher is to reverse the order of the letters in a plaintext. Another similar way to encrypt a message would be to reverse the letters of each word, but not the order in which the words are written. Another type of transposition cipher is the skytail, which was an encryption device used by the ancient Greeks and Spartans. Transposition cipher consisted of a polygonal rod or cylinder around which was wrapped a piece of parchment. The sender would write the message along the faces of the rod. When the parchment is removed from the skytail, it leaves a nonsensical message going down the strip. When the message is received, it is wrapped around a rod of the same size and shape as the original to reveal the original message. However, its importance lies in the fact that it is one of the first uses of tools in cryptography. The shift cipher, that is Caesar's cipher. In this video, we are going to learn about the shift cipher, that is Caesar's cipher. Shift cipher, also called as Caesar's code or Caesar's shift, which is the simplest and widely used known encryption techniques. It is a type of substitution cipher in which each letter in the plain text is replaced by a letter some fixed number of positions down the alphabet. Encryption. Encryption can also be represented using modular arithmetic by first changing the letters into numbers according to the scheme A is equal to 0, B is equal to 1, Z is equal to 25. Encryption letter X by a shift N can be illustrated mathematically as En of X is equal to X plus N mod 26. Here, the plaintext is shifted based on the key and obtain the resultant text called the ciphertext. Decryption. Decryption is similar to encryption, but here subtract the given ciphertext with the help of key and obtain back the plaintext that have been encrypted. dk of y is equal to y minus k mod 26. Shift cipher with key is equal to 3 is called as Caesar cipher. The Vigenere cipher. In this video, we are going to see about Vigenere cipher. The Vigenere cipher is a method of encrypting alphabetic text by using a series of different Caesar ciphers based on the letters of a keyword. It is a simple form of polyalphabetic substitution. Instead of being a one-to-one relationship between each letter and its substitute, there is a one-to-many relationship between each letter and its substitutes. The Vigenere tableau. Note that each row of the table corresponds to a Caesar cipher. The first row is a shift of 0, the second is a shift of 1, and the last is a shift of 25. The Vigenere cipher uses this table together with a keyword to encipher a message. For example, suppose we wish to encipher the plaintext message using the keyword relations. We begin by writing the keyword, repeated as many times as necessary above the plaintext message. To derive the ciphertext using the tableau for each letter in the plaintext, one finds the intersection of the row given by the corresponding keyword letter and the column given by the plaintext letter itself to pick out the ciphertext letter. Decipherment of an encrypted message is equally straightforward. One writes the keyword repeatedly above the message. The strength of the Vigenere cipher against frequency analysis can be seen by examining the above ciphertext. Note that there are 7 T's in the plaintext message and that they have been encrypted by H, L, K, M, G, X, and L respectively. This successfully masks the frequency characteristics of the English T. One way of looking at this is to notice that each letter of our keyword relation picks out one of the 26 possible substitution alphabets given in the Vigenere tabule. Thus, any message encrypted by the Vigenere cipher is a collection of as many simple substitution cipher as there are letters in the keyword. Affine cipher. In this video, we are going to learn about affine cipher. The affine cipher is a type of monoalphabetic substitution cipher wherein each letter in an alphabet is mapped to its numeric equivalent encrypted using a simple mathematical function and converted back to a letter. An encipherment scheme is E of x is equal to ax plus b mod 26, where x implies a numerical equivalent of the given plaintext letter, a and b implies appropriately chosen integers. The numerical equivalents of the letters are encipher. Consider this example. Encipher the word "it's school." Formula for encipher is E of x is equal to 5x plus 8 mod 26. A and b are appropriate integers. Here we have chosen 5 and 8. The numerical value is obtained from 5x plus 8 mod 26. This resultant value is mapped to the corresponding alphabet and the equivalent ciphertext is WZUSAAL. Decipher. Decipher HPCCXAQ if the encipherment function is E of x is equal to x plus n mod 26. From the encipherment function, we can easily obtain the decipher function. If y is equal to E of x is equal to ax plus b mod 26, then we can solve for x in terms of y and so determine E inverse of y. That is, if y is congruent to ax plus b mod 26, then y minus b is congruent to ax mod 26, or equivalently, ax is congruent to a minus b mod 26. Using our earlier results, we see that if we multiply both sides by a inverse mod 26, then x is congruent to a inverse y minus b mod 26, and so our decipherment function is E inverse of y is equal to a inverse of y minus b mod 26. We begin by finding the decipherment function. Since 5x is congruent to 1 mod 26 is solved with x is congruent to 21 mod 26, we see 5 inverse mod 26 is equal to 21. Therefore, E inverse of y is equal to 21 of y minus 8 mod 26 is the decipherment function. For the ciphertext HPCCXAQ, the plaintext is freedom. Basic cryptanalysis. In this video, we are going to learn about basics of cryptanalysis. Cryptanalysis is the study of ciphers, ciphertext, or cryptosystems, that is, to secret code systems. Analysis to discovering weaknesses in them that will allow the retrieval of plaintext from the ciphertext without necessarily knowing the key or the algorithm. This is known as breaking the cipher, ciphertext, or cryptosystem. Breaking is sometimes used interchangeably with weakening. It is identifying a property that is fault in the design or implementation of the cipher that decreases the number of keys necessary in a brute force attack That is, simply trying every possible key until the correct one is found. For example, suppose a symmetric cipher implementation utilizes a key length of 2 power 128 bits, that is, 2 to the power of 128. A brute force attack need to try up to all 2 power 128 possible combinations, that is rounds, for finding the correct key, or on average 2 power 127 possible combinations, to convert the ciphertext into plaintext, which is not possible given present and close to future computing capabilities. However, a cryptanalysis of the cipher discloses a method that allows the plaintext to be found in 2 power 40 rounds. The most common types of attacks are ciphertext-only attack COA, Known-Plaintext Attack KPA, Chosen-plaintext Attack CPA, Chosen Ciphertext Attack CCA, Side Channel Attack, Man-in-the-Middle Attack, Timing or Differential Power Analysis. Ciphertext-only attack COA. In this video, we are going to learn about ciphertext-only attack COA. In this type of attack, only the ciphertext is available to the cryptanalyst. This is mostly used in real-life cryptanalysis, but it is the weakest attack because of cryptanalyst's lack of information. Brute force attack. Brute force attack or exhaustive search. In this attack, all possible keys is tried until right one is found. It is not dependent on the cipher but only depends on the key length. If the key has n bits, there are 2n possible keys to try, so a brute force attack can break the cipher in a worst case time. This is mostly used as a standard of evaluation for other attacks. Known-Plaintext Attack KPA. In this video, we are going to learn about Known-Plaintext Attack KPA. The Known-Plaintext Attack KPA is an attack where the attacker has samples of both the plaintext and its ciphertext version, then he can use them to expose further secret information after calculating the secret key. In Known-Plaintext Attack, the pair of plaintext and equivalent enciphered text are accessed to the analyst. The key used to encrypt the plaintext is publicly disseminated and anyone may use it. This is called Known-Plaintext Attack. For example, an attacker with an encrypted zip file needs only one unencrypted file from the archive, which forms the known plaintext. Chosen-plaintext Attack CPA. In this video, we are going to learn about Chosen-plaintext Attack CPA. Chosen-plaintext Attack CPA is an attack model for cryptanalysis which assumes to the attacker have the ability to choose random plaintext to be encrypted and obtain the equivalent ciphertext. Goal of the attack is to gain some additional information which decreases the security of the encryption system. For some chosen plaintext attacks, only a small part of plaintext wants to be chosen by the attacker. These attacks are known as plaintext injection attacks. Chosen plaintext attacks become extremely important in the context of public key cryptography. Any cipher that can prevent chosen plaintext attacks is then also guaranteed to be secure against known plaintext and ciphertext-only attacks. This is a conservative approach to security. In the case of private key encryption, Alice and Bob share a key K according to the key generation algorithm keygen. In case of public key encryption, Bob generates a public key or private key pair so that the public key K is made accessible to both Alice and the adversary. The adversary Eve randomly interrelate with the environment, that is, to influence its choice of message in the next step. The environment sends a message M to Alice. Alice sends ENC K of M to Bob. Eve receives a copy of the ciphertext and then randomly interrelates with the environment to influence the behavior of the environment. The environment outputs a bit whether Eve caused a particular observable effect on the environment. The adversary is said to succeed in the experiment if the environment outputs 1. Two forms of chosen-plaintext attack can be distinguished: batch chosen-plaintext attack, adaptive chosen-plaintext attack. Batch chosen-plaintext attack. In batch chosen-plaintext attack, the cryptanalyst chooses all plaintexts before any of them are encrypted. This is often the meaning of an incompetent use of chosen-plaintext attack. Adaptive chosen-plaintext attack. In adaptive chosen-plaintext attack, the cryptanalyst builds a sequence of interactive queries, choosing successive plaintexts based on the information from the previous encryptions. Chosen ciphertext attack CCA. In this video, we are going to learn about chosen ciphertext attack CCA. In this attack, the cryptanalyst can choose random ciphertext and access to plaintext decrypted from it. This is used in real life because it needs cryptanalyst to have access to the communication channel and the recipient end. The adversary Eve randomly interrelates with the environment, that is, to influence its choice of message in the next step, and also sends ciphertext of its choice to Bob. If Bob has not earlier received this ciphertext from Alice, he decrypts it using the shared key or his private key and sends it to the environment. The environment sends a message M to Alice. Alice sends ENC K of M to Bob, and Eve also receives a copy. Bob decrypts it and sends it to the environment. The environment outputs a bit whether Eve caused a particular observable effect on the environment. The adversary is said to succeed in the experiment if the environment outputs 1. Lunchtime attack. Lunchtime attack or midnight attack. In this attack, cryptanalyst only can access the system for limited time or limited number of plaintext ciphertext pairs. Once cryptanalyst accesses the system, after he must show the progress. Adaptive chosen ciphertext attack CCA2. In this attack, analyst can select a sequence of ciphertext and see the resulting plaintext with a chance at each step to evaluate the previous ciphertext plaintext pairs before choosing the next ciphertext. Side channel attack. In this video, we are going to learn about side channel attack. Side channel attack is not strictly a cryptanalytic attack, and it does not depend on the strength of the cipher. It uses other data about the encryption or decryption process to get information about the message, such as electronic noise produced by encryption machines, sound produced by keystrokes as the plaintext is typed, or measuring how much time various computations take to perform. The unintended side channels can comprise the instantaneous power consumption of the hardware, radiated electromagnetic fields, or timing information, leading to what are appropriately named power analysis, electromagnetic analysis, and timing analysis, respectively. At times, secrets such as plain text can be discovered directly, but often the goal of the attacker is to determine the secret keys used to protect the data. In one of the simplest cases, simple power analysis (SPA), the bits of an important key might be seen directly in the power consumption of an integrated circuit using that key to perform an encryption or decryption operation. Man-in-the-middle attack. In this video, we are going to understand about man-in-the-middle attack. Man-in-the-middle attack involves tricking the individuals into surrendering their keys. Cryptanalyst or attacker positioned him or herself in the middle of the communication channel between two parties who wish to exchange their keys for secure communication. Cryptanalyst or attacker is exchanging the key with each party. The original parties believe that they are exchanging the keys only with each other. Finally, the two parties then end up using keys that are known to the cryptanalyst or attacker. Timing or differential power analysis. In this video, we are going to understand about timing or differential power analysis. Timing or differential power analysis is a new method made public in June 1998, particularly useful against the smart card. This measures differences in electrical consumption over a period of time when a microchip do a function to secure information. This method used to gain information about key computations that are used in the encryption algorithm. Differential power analysis countermeasures consist of a wide array of software, hardware, and procedure methods that defend interfere-resistant devices from side-channel attacks in a number of ways, including incorporating randomness, representing cryptographic midway in forms that incorporate unpredictable information to decrease correlation between side channels and the original intermediary. Amplitude and temporal noise. Accumulation of amplitude or temporal noise into the side channel to reduce S/N ratio. Balanced hardware and software. Using hardware and software-based method to represent and process data in ways designed to reduce visible data-dependent differences within the side channel. Leak reduction. Reducing information leaked into the side channel to reduce signal-to-noise S/N ratios. Protocol-level countermeasures. Altering cryptographic protocols using key update mechanisms to limit the quantity of side channel information available to an attacker for any particular key.